Hello everyone, today we'll be looking at chapter 7, and chapter 7 is on heat transfer. And generally there are three ways by which heat is transferred. It's one of the ways is conduction. Heat can also be transferred by convection and by radiation. So the aim of this chapter basically is for you to understand these three different modes. And some of the questions we want to ask ourselves is that if how is it possible for the solar radiation to be able to reach us on the surface of the earth, even though the distance between the earth and the sun is so vast. So the question of how is it possible for us to boil water and the entire area or surface or entire area of the water get heated up. The question of how is it possible for us to put the end of an iron metal to maybe a hot object, and it's possible for our hands to get burned within a period of time. Answering these questions will be able to help us to better understand the various modes of heat transfer. Like I said, heat is transferred through three different ways: by conduction, by convection, and by radiation. Now let's look at heat transfer by conduction. Now let's just take a particular example, and this example is a very simple one, and from there you guys can understand what conduction actually is. And mostly conduction mostly happens with solids, and the reason is because solids have what we call free electrons in the atomic nature or structure of that particular solid. Most solids have free electrons, and it's as a result of this movement of free electrons that heat is actually conducted from one end of a metal bar to the other. But now, how does that happen? Let's say we take one end of a metal bar and we put it we light it up, or let's say we put it in an hot object. Now what happens is that when that happens, that particular end that is heated up, the temperature increases, and as a result the atoms of that particular metal end begins to vibrate, they begins to oscillate because of the high temperature. And as a result of the interactions, vibrations that takes place between those molecules or those atoms in that particular head, they begin to collide with each other. And as the collision takes place, what happens with collision is that now one atom collides with the other, transfers its energy from the hot to the cold atom, and that collision keeps going from one end of the metal to the end, as from the heated part of the metal to the end. As a result of that continuous collision between these atoms, you see finally at the end of the metal, the hand holding the metal feels hot, feels warm, because of that particular process, which we generally call conduction. So like I said, it takes place from the region with a higher temperature to a region with a lower temperature. Now the example is very clear from the example we have right now. You see that Na is heated up, it's warm, it's a warm body. Now what happens is you see atoms of A are heated up, and they begin to vibrate and begin to interact with each other, and those vibrations cause the particles to begin to move from one point to the other and begin to collide with one atom. And as a result, when collision occurs, it transfers its energy to the other and sets the other on vibration, and this process continues until we get to the end of the metal. You see, at this point, let's call the point B, you see that as that process keeps happening, there will be a point in time when point B also will be heated up, and that process generally is termed conduction. So generally conduction basically occurs mostly in metal, in solids, and it's possible for us to divide solids into two different categories, general categories. We have metals and non-metals. Now the difference is that metals generally have what we call free electrons in the atomic nature. So we have free electrons, and those electrons are capable of moving around from one part to the other, and it's as a result of this movement of these electrons that actually heat is conducted. And generally, because of that, metals generally are regarded as very good conductors of heat, because for example, if you want to do electrical wiring in your house, most of the cables we have is made up of copper iron or whatsoever, because these elements or these devices or surfaces or whatsoever, they are very good conductors. So metals are very good conductors as a result of the free electrons that they have. Now let us look at non-metals. Now what non-metals are? Non-metals are, well, they have very few electrons, few free electrons relative to metals. And when we talk about non-metals, we're talking about objects such as wood, such as cloth, such as anything that we know that is not a metal, though they are solid, but they are not actually metals. So as a result of the absence of this transfer mechanism, that is because of the few free electrons that we have in these non-metals. Non-metals are relatively very poor conductors of heat, and in most cases we call them thermal insulators. So this is generally the three ways by which if I can divide or show you how metals are actually conducted. This is a mechanism that takes place. Now for one, you see, this is the structure of an atom. These are the structures that we have. So what happens is, in point 2, let's say we heat point, let's call this point A and let's call this point B. So point A is heated up, and as a result the atom starts vibrating. You see, vibrations takes place, and because it's vibrating, it sets this order on vibration and on this and this. So this is what we have. So we have this. So because this NA is set on vibration, it's heated up, it's vibrating. The atoms on side A, it's vibrating. It's because of the interaction between this atom and this and this other atom. This other atom also is set in motion. It starts vibrating, and it keeps doing. It's a process, a spiral process, and as a result, you see, at some point in time, the entire iron or metal will be heated up, and that's the mechanism through which heat is transferred by the method of conduction. And this slide tries to explain the exact same thing that I've been talking about: interaction, collision, transfer of energy from one atom to the other. So conduction, generally there is a transfer of internal energy by electron and molecular collision within a substance, which is exactly what I've explained before. And some of the examples that we have that involves transfer of conduction. So conduction, we said it occurs mostly in solids, and where the molecules remain in relative restricted location, which we've explained that when you stick a nail into ice, does cold flow from the ice to your hand, or heat flow from your hand to the ice? Now that's a very important question. Like we've explained, when we say conduction has taken place, we said it takes place from a hot body to a cold body. Heat is transferred from a hot body to the cold body. So if you are touching ice, so what actually happens, that heat is transferred from your hand, from your body, to the ice to warm up the ice. Though you feel cold as a result of that heat that is leaving your body, not because the ice is the heat or the cold from the ice is getting into your body. So let's look at the question like this: if you hold one end of a metal bar against a piece of ice, the end in your hand will soon become cold. Does cold flow from the ice to your hand? Now, that's a simple question which we have already answered. Is it yes? No. Cold cannot flow from the ice to your hand. But what happens? No, it's not possible. Cold heat has to flow from your hand to the ice, not the other way around. Okay. So conduction, in general, the ability of a substance to conduct heat depends on the substance phases. Gases are poor thermal conductors. Obviously, these molecules are relatively far apart, and collisions are therefore infrequent. So it's difficult for us to have collisions. So gases generally are very poor thermal conductors. Liquids and solids are better thermal conductors than gases because their molecules are close to each other and they can interact more rapidly. You remember when we're explaining this concept when we're talking about fluid flow. So an example of conduction, so we have this what actually makes there is a quantity, a property of a particular metal which we call the thermal conductivity, and is the factor that influences transfer by conduction. And substances with, if you have a very high thermal heat conductivity, you're going to conduct you're going to conduct heat more than a substance that has a low heat conductivity. So here we can see the different heat conductivities for different substances, and from there you can see that aluminium is a better conductor of heat than any of the of the substance listed here. And we can see that wood is generally a very, very poor conductor of heat. Now let's look at some of the applications that we can have. Snow patterns on the roof of a house show area of conduction and insulation, so you can see what's happening in the house. Bare parts show where heat from inside has conducted through the roof and melted the snow. So these are some of the applications that we can see. Now let's try to answer this question. When thermal insulation such as spun glass or rock wool is placed beneath the roof of a house, then in cold weather the insulation will... Okay, let's read it again. When thermal insulation such as a spun glass or rock wool is placed beneath the roof of a house, then in cold weather the insulation will create heat to warm the house, keep the cold from coming through the roof. C, slow the flow of heat from inside the house to the outside. D, stop the flow of heat from inside the house to outside. What's the answer? C. So the reason why we do that is because we want to slow heat from moving from the inside of the house to the outside of the house. We call that isolation, that insulation. That's why houses, especially in the US, they have a certain layer just to protect heat, especially during the winter period, from going outside of the house. So an example, we have good conductors and we have poor conductors. So good conductors generally are known as poor insulators. For example, a copper metal is a good conductor, but it is a very poor insulator. Examples, we have all metals. Now, poor conductors, what poor conductors actually do is that they delay the transfer of heat. They are also known as good insulators. And examples of poor conductors, we have wood, straw, paper, and all, and so forth and so forth. So next lecture we're going to look at heat transfer by conduction.